Imagine the entire universe squeezed into a space smaller than an atom. This incredibly dense and hot speck is where our cosmic story begins, with the Big Bang. About 13.8 billion years ago, this tiny point exploded with unimaginable energy. This wasn't an explosion space but rather the explosion space itself. The Big Bang theory is the prevailing model explaining the birth of our universe, not simply because it's a cool idea but because scientific observations support it. In the first fraction of a second after the Big Bang, the universe underwent a rapid expansion, known as inflation. Space stretched and cooled and energy began to transform into matter and antimatter. Most of this matter and antimatter annihilated, but thankfully, a tiny bit of matter survived. Think of it like baking a cake. You start with a few basic ingredients, and through a process of mixing and baking you end up with a delicious treat. In the universe's case, the ingredients were fundamental particles, and the baking process was the Big Bang and the subsequent expansion. As the universe continued to expand, it also cooled down. This cooling allowed for the formation of the first atoms, primarily hydrogen and helium. These elements, the simplest on the periodic table, became the building blocks for everything else in the cosmos. Over millions of years, gravity began to pull together clumps of hydrogen and helium gas. These clumps grew denser and hotter, eventually reaching temperatures and pressures high enough to ignite nuclear fusion. This is how the first stars blazed to life, flooding the young universe with light and heat. Stars didn't just exist in isolation though. Gravity continued its work, pulling stars together into vast collections called galaxies. Within these swirling galaxies, new generations of stars were born, lived out their lives, and died. Some of these stars ended their lives in spectacular supernova explosions, scattering heavy elements forged in their cores throughout space. These elements, like carbon, oxygen, and iron, became the ingredients for planets, moons, and even life itself. The idea of the Big Bang might seem incredible, but scientists have found compelling evidence to support it. One key piece of evidence is the cosmic microwave background radiation, a faint afterglow of the Big Bang that permeates all of space. Think of it like the fading heat you feel on a brick wall long after the sun has set. Another piece of evidence is the observed redshift of distant galaxies, which indicates that the universe is indeed expanding. Scientists continue to study the cosmos, using powerful telescopes and sophisticated instruments to peer back in time and unravel the mysteries of our universe's birth. By understanding our cosmic origins, we gain a deeper appreciation for our place in the grand scheme of things. We are all stardust, connected to the vast universe by a shared cosmic history. And as we continue to explore the cosmos, we may yet uncover even more secrets about the Big Bang and the incredible journey that brought us to this moment.